Transformed logarithmic functions. Communication question 1. Consider the logarithmic function log of x. It passed through point 1 with x-intercept at 1, 0 and vertical asymptote along the line x equals to 0. Explain the change in these characteristics for the following transformed functions. Log 2x, 3 log x, log of 2x plus 1 and 1 minus log x. Well, in this series of transformed logarithmic functions, I'm trying to explain to my students how the log function looks like, how it gets transformed, and how to write its equation. So most of the students are looking at it for the first time. I want them to have a very clear picture of logarithmic function before they get into numeric values and complications. So this is probably the most simplest form of transformed function. We have taken log to the base 10. And let me remind you, we normally don't write the base 10 here. If no base is given, that means it is to the base 10. Another reason to take log to the base 10 is that you can use calculator to find the values also, right? Now, we are given the critical characteristics of any log function in general here in the question. So when we say consider logarithmic function log x, it could be any function. At present we have taken log to the base 10. So it passes through 10, 1, right? So that means the point at 10 is this. So this is the point 10, 1. So log to the base 10 of 10 is 1, right? Now, with x-intercept at 1, 0, so that is the x-intercept 1, 0, correct? And a vertical asymptote along the line y-axis, along the line x equals to 0. So y-axis is normally the vertical asymptote of a base function, right? Explain the change in these characteristics for the following transformed functions. So this is our base function. You can call it a parent function log to the base 10 of x. Now, we'll see how it gets transformed with each of these transformations, correct? Log 2x. Now, what kind of transformation will that result into? So, we have log of 2x. So, think like this. It is like within the brackets. Do you see that? There is a k factor in your log. So, that will give you horizontal compression by a factor of half. Do you see that? So, that is the change which log of 2x will bring. So it's a horizontal compression by a factor of half, correct? So what will it do? Horizontal compression means that this point is at 10. Horizontally, this will move to half of this value, which is 5. So we'll move this point from here to here. So it comes here. And this point, which was at 1, will move horizontally to half. So horizontal compression by a factor of half means this. So every point in fact moves half times, left or right. Do you see? Depending on where it is on this axis. Since all the points are on the positive side, so they move inwards. And this is like 5. So half of 5 is 2.5. So this is 1, 2, 2.5. So this point will move horizontally to 2.5. Do you see that? And now I will have a function which is kind of, so this line is too difficult to imagine. So there is a vertical asymptote here. It remains same. There is no change as far as the vertical asymptote is concerned. But as far as the function is concerned, what you really see is, there's not that good a diagram. But the emphasis here is that every point move half units inwards. Do you see that? So what will it change? It is not going to change your vertical asymptote. It is going to remain same. Vertical asymptote remains same. But what changes? So I will write down the values which change here, right? So what changes are, with respect to these points, that x-intercept, which was at 1, 0, comes to half 0. Do you see that? So one point is we have half 0, and that is the x-intercept, correct? And the other point, which was at 10, 1, actually moves inwards, and we can see that point at half the distance, right? So the x values change. Do you see that? So that is what is happening. correct? Vertical asymptote remains same. If I multiply 0 by half, I still get 0, correct? So that x value doesn't change. You see the change which comes from log 2x. Now let's consider 3 of log x. So I'll use a different thing to show you what happens with 3 of log x. It is a vertical stretch by a factor of 3, correct? So this point remains same. 0 times 3 is 3. But this point, which is, these points will be 3 times up. So 1 will move up to 3, right? So this is 2 and probably this is 3, right? So this point will move upward. So it is getting stretched vertically. Do you see that? So that is what happens, correct? So all the y values gets multiplied by 3, x values remain same. Do you understand? So these values here, 10 becomes, instead of 1, it becomes 3 times. Do you see? But that remains same. So I'm not writing the values which are remaining same. Which remains same, remains same. Do you see that? So that remains same. But all other values in between, so it kind of gets stretched. Do you see that? So every point here will get stretched, correct? Now, if it is at minus thing, it is coming minus down. So it will be like kind of here. Do you see that? So the graph will actually look like this now. Do you understand? So it will kind of stretch, negative stretch. And on the positive side, it is kind of moving like this. Do you see? And that point will be at 10.3. So let me write 10.3 here to be very clear about it. So that is what is happening with a vertical stretch. It stretches vertically, both positive side and negative side, correct? Now let's look into the third function, log 2x plus 1. It is kind of tricky, and many of my students don't really see it like this sometimes. So what is important here is there are two things happening here. One is kind of log 2x, which we have already considered, right? The second one is a horizontal translation. But by how much? By how much? That's a critical question. So how do we find that, right? So for that, what do? We factor out 2. Let me write this equation separately here, correct? So I'm writing c as log of, so I'll factor out 2. It is very important to factor this 2 out so that you can appreciate what is really happening, right? Plus, when I factor 2 out, I get half here. Do you see that? I get half here. So one part is clear, what really happened earlier with log of 2x, that is all these things get horizontally compressed by a factor of half, correct? So they come like that orange line which we have drawn. But apart from that, what happens here is that the graph moves half unit to the left. Do you see that? Half unit to the left. And therefore, we'll have a vertical asymptote not at x equals to 0, but at minus half. So that is the major change here. So what changes here is the vertical asymptote, right? And all these points, they do move half units left. So we have these changes plus one more. And that is, in this case, the vertical asymptote is not at x equals to 0, but it is at, let me write in ink, x equals to minus half. So that is a major change which is caused because of this plus 1. Why is it minus half? Because you need to factor 2. Don't forget that. Sometimes students make a mistake and they just write minus 1, and that's a huge mistake. You need to factor 2, and then it is a vertical asymptote. So we have a vertical asymptote at x equals to minus half in this case, right? So this orange line actually shifts half units to the left, half more than what it did earlier. Do you see that? So first is compression by a factor of half. So we came here, right? So that was the compressed points, and then it is moving. Let me take another ink. And then it is moving half units, right? So this compression and then moving half. So further translation of half. Do you see that? Compression and moving half units. Compression and moving half units. So that is what it will look like, kind of. It will be like this, right? So this is your graph, which will be for log of 2x plus 1. Do you appreciate that part? So this is your graph for log of 2x plus 1. It's kind of same thing, shifted more half units to left. That is what is this function, correct? Now Now we look into part D, which is 1 minus log x. So we'll again go back to our original function, and this is that black line is the original function, right? So it is 1 minus log of x. You could see this as like this also. Minus, I'm rewriting this, log of x plus 1. I hope for many students this makes things much clearer. Minus means reflection. So these points get reflected and you get a function like this. Do you see that? And it gets reflected over, and therefore instead of this we have a point here, and instead of this we have kind of point here, right? So we have a graph which is, let me draw this here like this. So that is the effect of minus log. So minus is reflection, correct? Minus is reflection on x-axis. So that is the first part. And second is plus 1. So what does this plus 1 do? Plus 1 moves it 1 unit up. Plus 1 moves it 1 unit up. So this gets reflected and then it moves 1 unit up. Do you see that? It gets reflected and moves 1 unit up. So that is the final position of your graph after doing both the operations, reflection and 1 unit up, right? Do you see that? So that this point now comes here. So we have a graph which is kind of like this, right? It moves 1 unit up, correct? So that is your final log function for part D. I will like you to write down all the transform points for this last function yourself, correct? So here what is happening? X values are remaining same, correct? So these x values will remain same, but the y value changes. They get multiplied by minus 1 and add 1. So this point transforms. So 10 will remain as 10, but 1 will get multiplied by minus 1. So 1 times minus 1 is minus 1 plus 1 is 0. And that is this point. Do you see that? Now x-intercept, which was at 1, 0, will be at x equals to 1 instead. What will happen as 0 plus 1 gives you 1, and so that point moves to 1, 1. So that is this point. Do you see that? So that is how these points are going to shift. Nothing changes as far as the vertical asymptote is concerned. Do you see? So vertical asymptote will not change by a vertical stretch or a compression or a vertical translation. Vertical asymptote only changes if there is a horizontal translation. Do you understand? Only for horizontal translation, which we saw here, will make a change in the vertical asymptote and no other transformation, correct? I hope this gives you excellent idea about the graph of this function, logarithm function, and its transformation, and also tells you which transformation affects which characteristics. So these characteristics which we are talking about are the major characteristics which we have to consider always, right? Now I forgot to tell you about one major characteristic here, and that is domain, right? So I like you to include the domain also. For a logarithmic function, domain is x belongs to real numbers where x is greater than 0, correct? So domain is restricted for a logarithmic function. For all these, domain will be greater than 0 except for where we had a horizontal transformation, correct? Here the domain is greater than minus half. And then range, right? So range for logarithmic function is y belongs to real numbers, right? So there is no restriction on range. As you know, it is inverse of exponential function. Exponential functions have restriction on range, not on domain. So for exponential functions, domain is all real numbers and range is restricted. But for logarithmic functions, it flips. Domain is greater than 0, restricted, and range is all real numbers. I hope with this you get clear picture of logarithmic functions. Thank you and all the best.